Hello students and welcome back to my channel. This is the Nutritional Toxicology series of videos, and today we're going to continue by taking a look at the controversial toxicology. So expect to learn about the fluoride, the radionuclide and the irradiation toxicity, as well as what the endocrine disruptors can do to our body. Hi, I'm Tommy. I'm a human nutrition student and researcher at the university. What I do in this type of videos is to synthesize my classes so then I can explain and teach you the best and most valuable information you need to know. So let's begin this video by taking a look at fluoride. So fluoride is the most reactive element of the periodic table. It's a trace element. The benefits of it is a lower tooth decay, better mineral structure, higher acid resistance, lower carcinogenic bacteria, lower osteoporosis, and a higher bone hardness. Seems very good, right? The sources are natural through volcanic soils or anthropogenic, fluoridated waters. The absorption, mainly via digestive tract, liquid state, 95 to 97%, that's why they put it in the water, and in solid state, 60 to 70%. The metabolism interfered by corticosteroids, and the excretion is through the urine. A deficiency in fluoride will give us dental caries and osteoporosis, but an excess will give us dental and bone fluorosis. Mechanism of action, it's a metabolic blockade creating an amino acid disorder. In acute poisoning, there is a potent irritant compound, inhalation, dermal and gastrointestinal routes, leading to necrotic lesions. And in chronic poisoning, there is a calcification or acidification, a spastic paraplegia, an interference with iodine metabolism, and a cytochrome oxidase. It will also lower fertility and IQ. Not to mention that the calcification is also associated with the pineal gland. Fluoridation. Nowadays they fluoridate almost everything. Water, food, salt, milk, flour, and even supplements of fluoride you can find out there. The topical application is best for the tooth enamel protection. That's why they put it in the toothpaste. And the endemic fluorosis is when you have a lot of natural presence of this mineral in the soil. For example, in a volcanic island, there is a lot of fluoride in the soil. The regulation, well, it's not included because the main source of it is the drinking water, not a solid food. Then we have the radionuclide toxic risk. You have to know that the radioactivity is measured in the sievert or becquerels. The sievert is the more accurate one, but the becquerels are the systemic units. Radioactivity can come from a fusion or a fission because of an unstable nuclei of an atom, and this will create radioactive isotopes. The exposure can be either natural through food, soil, atmosphere, water, fish, seafood, and reindeer, or through an artificial, such as medical applications, fuel hash, nuclear power, in testing, contamination, bombs, and accidents. Talking about accidents, we have to mention Chernobyl, because this event is now used as a disaster prediction. And when it happened, there was a distant radiation detection. It affected meat, milk, greenhouse crops, and there was an added radiation in distant countries as well. And the bioindicators for this radiation are the fungi, the lichens as absorbers of radiation. And then there is also the Hiroshima and Nagasaki examples where a lot of radiation will raise the cancer rates. There is no genetic investigation because the DNA was still unknown at that time, but there was a lot of teratogenicity, and they discovered even Arctic ice contaminated with polonium. The toxic effect of radionuclides are in acute exposure, cell tissue damage, corrosion with the bone marrow because it can cause leukemia, corrosion with the lens and with the testicle, and a chronic exposure, carcinogens, mutagens, and teratogens, genetic effects, of course, and thyroid anomalies. That's why they tend to prescribe a lot of iodine when there is a lot of radiation. Prevention, rapid harvesting, impermeable materials, deep plowing, bentonite, and also hexacyanopherates. These are all measures we can use to prevent the radiation from contaminating our food, mainly. Safe limits are established by scientific committees. In Spain, there is no elevated radiation levels. There are rare positive values, so it's not really a big deal here in Spain. And the studies are conducted through transitory, integrative, and accumulative pathways. And then, as we mentioned radioactivity, what about food irradiation? The first discovery of food irradiation was in 1943 by Mink, a German that discovered the bactericidal action of X-rays. The results? A reduction elimination of microorganisms and parasites, delayed germination of certain vegetables, and disinfection of crops. The effects? Elimination of toxic substances. Okay? No improvement in nutritional quality, improved hygiene state, and extended shelf life. An appropriate irradiation should have a wavelength of 10 elevated at 3 to 10 elevated at -1 and a power of 10 elevated at 2 to 10 elevated at 6 electron volts, being the upper limit 13 to 16 millielectron volts. The doses. Knowing that we have the low, which is below 1 kilogray, this is for insect disinfected food and delayed food ripening. The medium, from 1 to 10 kilograys. This is for pasteurization-like effect, decreased pathogen concentration, and increased shelf life. And then we also have the high, which is over 10 kilograys. This is for sterilized food and commercial preserves. The legal standards, they said that in 1980 the maximum dose of 10 kilograys is safe. In 1999, they even considered that doses higher than 10 kilograys were safe. But in 2003, the safety of the doses more than 10 kilograys could not be ensured. And the authorization nowadays is only in dried herbs, vegetable spices and condiments, and always not exceeding 10 kilograys. And if they are treated with irradiation, they must be labeled. There is even a symbol of irradiated food. The effects on food components, well, ionization and formation of highly reactive free radicals. Changes in nutrients. We have water radiolysis, carbohydrate shortening and degradation, protein denaturation, lipid oxidation, and vitamin destruction. Microbiological considerations. There is a reduction elimination of microbiota and pathogens because it affects the DNA and the cytoplasmic membrane of those microorganisms. And the resistance depends on the dose, temperature, environment, and the simpler life forms are more resistant. The concerns are with selective effects of food microbiota, the mutations it may have, an increased irradiation resistance, and also a toxin production because of this radiation. And the toxicity, well, subchronic toxicity, few adverse effects. Reproduction and development, no significant differences. Carcinogenicity, no carcinogenic effects shown in the recent studies, and genotoxicity, there are contradictory results, but no studies showing genotoxicity in humans. And now we have to talk about endocrine disruptors. These are chemicals that will alter the hormonal balance and therefore the human health. The effects: lower sperm count, lower quality and motility of them, higher effects in newborns, and a significant public health issue. The mechanisms: they block, mimic, or decrease the hormonal response. Types: we have natural hormones, such as estrogens, testosterone, and progesterones, or synthetic substances. These can be synthetic hormones, such as pharmacology, oral contraceptives, or for animal feed, the clenbuterol, for example. And also the synthetic chemicals, with an unknown property of being hormonal substances. These are, for example, cleaning agents, pesticides, plastics, food additives, and dioxins. The effects on the animals: altered hormones, fertility, sexual behavior, immune system, and anatomical alterations. The effects on humans: adverse reproductive effects, fetuses problems, lower reproductive health, and malformation of reproductive organs. An example of this is the problem with estrogens. Estrogenicity is indeed a chronic toxicity which will occur in agriculture and food processing, affecting then the human. And the risk assessment said that there must be limitations. It is a persistent and bioaccumulative endocrine disruptor. Specific examples of endocrine disruptors: we have the diethyl-estylbestrose syndrome, which is a synthetic estrogen in pregnant females, and the daughters of these females that were treated with the diethylestylbestrol had abnormal pregnancies, a reduced fertility, and even autoimmune diseases. The cryptocardism, which is undescended testicles, is linked to cancer and infertility. And this was due to the maternal estrogen drug administration. These were contraceptives. And the phytoestrogens found in plants like the clover, the human exposure to phenolic compounds, and the risks were infertility and developmental problems. The endocrine disruptors in food, we have natural and environmental contaminants, processed products, and agricultural residues. It is a diverse group and not causing acute toxicity, and it is detected variably over time. Examples of these endocrine disruptors in food are dioxins and furans, polychlorinated biphenyls, pesticides, endosulfan, hexachlorobenzene, phthalates, alkyl phenols, and bisphenol A. And talking about bisphenol A, the endocrine disruptors and public health, the bisphenol A is used in plastics and resins, leaching when heating the container, and is used for can coatings and dental sealants. The bisphenol A is an endocrine disruptor present mainly in the plastic bottled mineral water. That's the main way of exposure. And the safety limit is lowered by 20,000 times in recent years because they discovered it's far more dangerous than they thought it was. Right now, with half a liter of water, you are exposed to BPAs. And there are possibilities that they will completely ban it in a few years. Okay, this is it for this video. I hope you understood everything I said. If you didn't, there is a comment section down below. Don't forget to like, subscribe, and turn on the notifications so you get notified every time I upload a new video. If you find value in this, please share it to your friends and family to spread this knowledge to them as well. Thank you so much for watching, and I will see you in the next one, in which we're going to talk about the toxicity of mushrooms and mycotoxins. I will see you there. Hope you enjoyed. Ciao!